5 times 5 is?
25.
Yeah. Hey folks, welcome out there. You know, it is, what day is it? It's Wednesday, isn't it? It's the middle of the week, and we're so glad you've tuned in this afternoon. I'm Ernie Roberts, I'm your host. I'm happy you're here. I'm happy that I'm here too. I love doing this show, and I enjoy it when you guys call in. Hint, hint. 844-686-2378. Give us that call. You know what? They are so faithful, these two young volunteers, back again from Bearden High School, Malachi and Haley. There we go. We're so glad to have you. It's Haley. I'm sorry, I got that wrong again. Haley and Malachi. Yes, give them a call. We need them to get busy, all right? From Bearden High School Key Club, we are so glad to have them with us this afternoon. I'm happy they're here, and I hope that you are too. Now, again, give us those calls. You can talk to them. They will send you right in here, and we will work out some problems together, you and me, live on the air. That's the way it works for those of you who are tuning in for the first time. And those of you who are tuning in the first time, and the rest of you all know it already, but we're going to start with that tradition called Problem of the Day. Let's see what we've got going today. It says, find the next two terms in this sequence of numbers. Oh my goodness. 1, 3, 7, 15, 31. And explain your pattern. Oh my goodness. Well, you know, you look at those numbers, you kind of say, well, Ernie, what kind of relationship do we have going on here? So let's play with these numbers a little bit. So let's take it down, look at the thing here. And first thing I always think about, first of all, when I see numbers that are kind of jumping around, because these are not really in a, quote, arithmetic pattern where they're going up by 2 each time or going down. Or the next thing I want to know, well, are they multiplying by the same thing? Well, let's see. We multiplied maybe about 3 to get to 3, if we're going to look at it being geometric sequence here. But 3 times 3 would get me to 9, so it's not geometric either. But something is going on here. There is a pattern. And actually, my friends, there's more than one way to figure it out, all right? Now, let's see how it's going to work, what's going to happen. I'm going to rewrite it down here so I can mess with it a little bit. We got 1, 3, 7, 15, 31, and then we're going to look for basically the next 2 blocks. We may need to shorten it up just a little bit there. All right. See, what are we going to do? Well, what are we going to do? Let's check. First of all, let's see what's going on here. Let's get what we call a first difference situation. The first difference just means we're going to subtract and see if there's some sort of a pattern going on here. First difference says we have 2. The first difference here says we have 4. I'm already seeing hopefully what's going to be a pattern. Let's make another difference. How about between 7 and 15? We get an 8. Are you all seeing what I'm seeing? We'll find out in just a second. I'm going to put one more up here and say, I hope the light bulbs are turning on at home. What we got going on here? It looks like we've got a 16. Now what I'm catching on here is that what's happening each time? Now we are doubling. We are doubling through here each time. You got that? You see where we're going on that? And if we even started that, we'd still be doubling, wouldn't we? We'd be 2, then we'd be 4, then we'd be 8, and so forth. So it's really kind of all we need to do is notice there's the pattern right there. There's a nice differential going on. And what do you think? We've been doubling, right? And we added to that number. So how about it? Let's say double 16. We are going to get 32. And 31 plus 32, I'm catching 63. That's when you go like, wow, Ernie, maybe that works. Hope it does. Hope it does. And continuing on, since it seems like this pattern keeps grinding itself out, double the 32. Let's make a double 32. It's going to give us what? 64. So put the 64 right there, and we shall add, and I'm getting 127. Now, I haven't been on Facebook to check, see how our faithful folks who follow us there have been at picking up the numbers today, but I'm hoping they got those two, all right? I'm going to find out probably after the show's over, and I'll be able to say kudos to you guys. I said there's another way to figure it out, but does this make sense? You got a difference. You doubled that difference this time. You doubled it again. You doubled it again. And now you're starting to use that 32 to add to the next number and do the same thing there. That's the way I would probably have worked it out. But there is another option. Some of you go like, wonder what he's going to do now. I'm seeing some numbers here, this 2, 4, 8, 16, 32, 64. Those numbers are churning in my brain, okay? What little brain there is up here. Yes, folks, we have one sometimes. they're making me think something's going on, like maybe we're talking a power of 2 involved here. You say, what do you mean? Well, each time I'm increasing what? By this 2 to the whatever power it is, so perhaps I'm getting a 2 to the first, which gives me 2, and if I could subtract 1, I'm going to get 1. You say, well, that's pretty obvious. But look what happened. First term, 1. So far, so good. Now, once we blow it, in other words, once I come up to a point where I can't continue on with it, then guess what? It wasn't a good function rule, okay? It wasn't a pattern that's going to work. How about 2 squared? So I'm going to say, and I'm going to say subtract 1. I'm going to do the same thing. So in other words, I've got the second term here. I'm going to raise 2 to the second because it's the second term. And then I'm going to subtract 1. And guess what I get? I get 3. Well, there's that term again. My goodness. Can I do some more? Of course I can. How about it? 8 is 2 to the third. Let's try it. 2 to the third, subtract 1. What do we have? Oh my goodness, that's 8 minus 1. That's 7. Look what's happening, my friends. We're getting a pattern. And I'm thinking it's going to keep working, at least for where we're going. 2 to the fourth, 16. Subtracting 1, you get 15. 2 to the fifth, let's see if it works for our next one, which we had to find. No, we hadn't had to find it yet, have we? That's 32 minus 1. So we're at 31. Let's find that sixth term, 2 to the 6. You know what it is. 64 minus 1, which will give you 63, and we can play it up to the 7th. Now remember, 2 to the power, that's like 2 to the 4th means 2 times 2 times 2 times 2. It's not 2 times 4, but it's 2 times 2 times 2 times 2, which gives us that 16. 2 to the 5th power was, put another 2 in there, that doubled it one more time, you're up to 32. 2 to the 6th gave us the 64. Each time we're dropping off 1. So what's the pattern here that we could explain this? I think there's first that you can see the common difference. It's doubling each time. That's a legit way to do it. All right, fine and dandy, you add it to it. But this one also, you could have a y equals 2 to the n for the number of term and subtract 1 from that, where n equals the number of the term. And by that I mean, is it the first term, second term, third term, or whatever, okay? And that's another way of doing it. Quickly, can we graph it on the graphing calculator? Let's take a look at it real fast here. And if I were to go 2 and raise it to the x power, because that's all the calculator knows is x and y, right? So we'll put a 2 there. And we're going to raise it, not to the 1 or what, we're just going to raise it right on up there to the x. Go ahead and cursor over saying we're done with that exponent and subtract your 1. And let's see what kind of graph we get. Now remember, this is going to be beyond, we're looking at just integers here. This is going to give us a whole smooth graph, but what we can do is plot on this, we can check our points, all right? That's what I'm after here. Let's trace real quick. So does it work? Again, you all saw my multiplication, those you like to figure out. How about with the 3? We said it was going to be 7, right? So 2 to the third, press enter on the trace, go to the trace. We got 7. How about that? That's lovely. How about our 4? Trace it. Now it's going to go off the screen, friends. I'll go ahead and tell you that. But look at that. We got 15, which is the number we were looking for our 4th term. And then one more time. How about with the 5? Guess what? We press enter. We're at 31. I wonder if 6 will pop up. Sometimes we get out of range at a certain point. It doesn't like us anymore. That's still going up to 63. Everybody hold your breath. Let's try for 7. 127. There we go. Those are our numbers. Lots of ways we can figure it out today, all right? And some of you just may have gotten some mental arithmetic going with it, but those are the 2 main methods that we've got, using finding that first difference and noticing a pattern emerging from the first difference, and then playing it out. Others, noticing, oh, there's an exponential going on here. Actually, it is 2 to the nth power, and you're subtracting 1. So either one of these, my friends, will get you that number. I think that's pretty cool. There is more than one way to get out of that problem. All right, and that's your problem of the day. Kind of more than maybe what some of you were anticipating here about, but there you have it, all right? A nice little way to work out a problem and 2 options, all right? Now, next problem we have, we've got 2 young folks out there from Beard and High Key Club. They need to be getting some phone calls, all right? They're giving of their time this week. They're going to be on spring break next week, so they're getting excited about it. But they're here, and they're helping us out. So, folks, give us that call. That's 844-686-2378. We want to hear from you. I want to hear from you. I want to talk to you. Because you know what I've said, and it's true, when y'all call in, the show really does rock. We'll have some good stuff going on without you, but we really would like to have you as part of the game, all right? So keep those calls in, all right? You can always get us on Facebook. You can always get us on YouTube, but you know what? You're live right now. We're live. Give us a call. I would love, love, love to talk to you guys, all right? So speaking of one of those things we've got going along here, we've had this problem of the week going on, and it's now gone on 2 days. And yesterday, I gave away a lot of things, evidently, when we started working. But, you know, it's amazing. When you put information on a piece of graph paper and see the picture, things just start happening. So let's go back and review for those of you who may be just tuning in with us for today. And so, what are you talking about? Let's see what I am talking about. We've got this situation here, and notice we've already worked through a certain part here. We are going to write the slope-intercept form. By the way, that's y equals, the hint I gave you. We're going to use y equals mx plus b. And the first day I said, you need to find the midpoint. And how do you find the midpoint? There's a little formula where you add the coordinates for x, add your two x's, divide by 2, which is basically finding an average. Add your y's together, divide by 2. Since there are 2 of them, it is. It's finding an average. And we put the numbers in there, and we came up with this lovely midpoint, 1, 3. And then yesterday, we took a different level on this. We said, well, let's go to graphing paper. So let's do it. All right, can we switch off just a second, guys? Thank you. And here's where we went. Aha! We plotted the 2 endpoints. It makes a little more sense. And we drew that line segment. And we're looking for the midpoint. According to our calculation, it was at 1, 3. Well, look how it physically looks to us there. How about it? There are our 2 endpoints. There's our midpoint. Yes, friends, that piece is exactly congruent to that piece. Same length, same distance, same measurement. Yeah, we could figure out the length, but that's not our calling right now. What we also need to do is figure out what is that slope. And that's real easy once you've got it on the graph. You can spot that really very easily. So let's see what we've got. We've got going down 3 over 1, down 3 over 1, and that gave us -1 for the line segment. But, oh yes, there's always a big but there, right? We are looking for the perpendicular bisector. And you say, well, what does that mean, Ernie? That means we're looking for a line that's going to slice right through that midpoint. Because not only is it going to go in there perpendicular, it's going to bisect. Bisect means 2 congruent pieces, 2 equal length segments there, all right? That's what we're looking for. So we're basically saying these 2 are going to be equal to each other because, well, that's the midpoint. That's the way it works. Segments are congruent that are formed there. They have the same length, therefore congruent. Now, the slope stays the same because we're on the same line, or in this case, on the same line segment. So what I'm thinking is, what does perpendicular and slope have to do with anything? If you have a -1 slope, in perpendicular, we're looking for what? The opposite reciprocal. What is the opposite reciprocal of -1? Well, first of all, opposite means we're going to change signs, so we're looking positive. Reciprocal, hey, 1 over 1, it's 1, all right? So it looks to me like we're going to go positive, we're going to keep the 1, and we're looking for a slope of a line that goes through this little segment right there at its midpoint. Are y'all ready for the big deal? Let's put it together. Let's draw a picture of it. Let's put in, how about it? What are we going to do? We're going to go up 1 over 1, and that's over to the right, okay? Because it's positive. So we're going up and to the right. Remember, this new slope that we're looking for is 1 over 1, or 1. Keep doing it. Game plays again, you get the idea. Looks like here comes a line coming through here. Where is it going to land? Because that's what we're looking for, right? Slope-intercept form. Let's see if I can do it straight, because this is really nice to make it straight, Ernie. Got a lot of people watching out there. And there it goes, boom, boom, right through here and right through there. So you say, what's the deal? And notice, my dear friends, no matter what kind of ratio you've got your television working on, I think you're seeing what? We have right angles there. That's what's to happen. Perpendicular lines make right angles. So here we go, pretty straightforward here. We have slope of 1. So let's write these notes down here. I'm going to put it down here. I think we're about to need to drop our ball. Thank you, guys. M equals 1. There's the intercept. So 0, 2, I ask you on the problem of the day, let's write it y equals mx plus b. Slope is 1. So it's like saying 1 times x. Well, guess what? That gives us x. So let me write it down just for case some of you forgot from the other page there. We're looking for this y equals mx plus b business. We've got m. We have b. That's b right there, the number 2. So here we go. Y equals x plus, you got it, 2. And my goodness, look what happened. Does it pick up 1, 3? It certainly does. Put a 1 in there for x, add 2, you get 3. So it fits that requirement. It fits the perpendicular requirement. And my goodness, it passes right there where we want it, and it makes nice right angles. What more could you ask for? There's your problem of the day solved. Now, tomorrow what I may do, probably will do, is let's suppose we didn't have that pretty graph to help us and see what we can do with it, all right? Another option where we just simply use the whole concept of, hey, let's write this thing using a point slope approach. And I still like being able to get it onto a grid. I think it's so much quicker and easier to put the picture there. But a lot of times your teachers want to see all the different methods. I know. So we'll look at that one again tomorrow, a little bit deeper, okay? In the meantime, now that you've had a little bit of algebra and you had a little bit of, my goodness, some numerology going on there earlier, let's see if we get those phones ringing, all right? 844-686-2378. Let's see what's going on in your math world today, not just mine, okay? We do have, while we're waiting for you guys to call, and the Bearden Key Club operators are really wanting to hear from you out there. Let's get them busy. They've made, like I said, made their time today, and we want to make sure they will come back because they've been great whenever they've been here. We've been hearing a lot from you guys when they're here, so don't let them down. Don't let them down. Give us a call. 844-686-2378. How about a Hey Mathline, guys? I understand we've got one waiting in the wings here.
Hey Mathline, this is Mackenzie from Carter High School in Knoxville, Tennessee. Can you tell me how to raise 2/3 to the negative 4 power?
Hey, Carter High School, so glad to have you. And by the way, we were at this Ripley's Aquarium when we put this together. And, one of these fractions, and we're raising it to a negative 4 power. All right, so the negative 4th power. Wow, let's see what's going to happen here. All right, first of all, 2/3. We love fractions. We do. We love them on Mathline. And if I were just to look at that fraction and have to put an exponent on it, I would say that is 2/3 to the 1 power. All right? A good friend of the aquarium from Carter High School here in Knoxville, Tennessee, by the way. Some of you may be wondering, where is Carter? It's in Knox County, and it's in the eastern side of Knox County, and we are proud to have them in this county down here in Tennessee, East Tennessee. And you raise anything in the first power or 1 power, you have 2/3. Now, let's go a step further here. What if I wanted to take 2/3 and take it and square it to the 2nd power, if we will? And I have a lot of times students that say, oh, it's 4/6. Well, 2 times 2 does give us 4. But 3 times 2 is not what we're doing here. We're squaring it. So this would be 2/3. This would be 4/9. And if I play it one more time, I've got 2/3, and I'm going to raise that to the 3rd power. So this time I'm going to be saying, this is like saying 2 to the 3rd, 3 to the 3rd. Now you say, where are you going on this? Well, first we're going to see what happens if we raise it just to the 4th power. And then we're going to see what happens with a negative situation. So looking at where we are, and do I have room for one more? I don't think I do, but we'll play it out here. This is going to give us 8/27. Now where did I get 27? 3 times 3 times 3. Very straightforward, right? This gives you 27. 2 to the 3rd is 2 times 2 times 2. Again, it's so tempting to say, oh, 2 times 3, but that's not the game plan here. This is the base, that's the exponent, raise it to that power. Now, the next level is going to be 2/3 to the 4th. I'm about to run into my picture, so I'm just going to put it down here. That would be 16. Remember, we did those with that 2 power earlier. It's pretty nice to have this going along here. And then, what's going to happen? 3 to the 3. Oh, I think that's 81. It's getting pretty big, isn't it? That'd be basically like 9 times 9, because 3 times 3 gives you 9, then another 3 is 27, another 3, 81. So see what's the pattern going here? Now, that's if we had 1, 2, 3, or 4th power. Ooh, we got a negative from our friend in Carter. So let's see how that's going to work. First of all, let's go back to the first thing. By definition, if I say 2/3 to the -1 power, and this is one of the things in that pre-algebra vein or in that 8th grade math and that, algebra 1, when you really are saying, we got to do it now for sure. This simply says, take the reciprocal of the quantity. Take the reciprocal. Reciprocal of 2/3 is what? It's 3/2. So there's the difference. See? Reciprocal time. Now notice I didn't put a negative on there. It's not a negative value. It's just a reciprocal. It was positive to begin with. Its reciprocal is still going to be positive. All right? This isn't like perpendicular. We're looking for the opposite reciprocal. Nay, nay. All right? Well, we've used a lot of reciprocals today, haven't we, already? Now, let's play this thing out. What happens if we have 2/3? We raise it to the -2. That means we're going to take the reciprocal. Oh, and while we're at it, we're going to change that exponent to become positive. So it's going to be like taking 3/2 to the 1 power. All right? So let's see what happens here. We've got 3/2, and we're going to raise it to the 2nd power. That's the effect of what a negative reciprocal does. And by the way, that's going to give us what? 9/4. So we're getting there. Well, thinking of the pattern that we've set here, we're keeping it positive. We're making reciprocals. We're raising it to a positive exponent after we lose the negative, because that's what the reciprocal basically says. Use a reciprocal, go positive on the exponent. So here's our next trick. We've got 2/3. We're going to raise that to the -3 power. And we get, it's like saying 3/2 to the 3rd. And now I'm at 27/, you got it, 8. Now, I want everybody to start seeing as I'm boxing these in, see how they compare here? Reciprocal. There it is. Reciprocal. Reciprocal. Wow, sounds like a call. Reciprocal, reciprocal. Guess what's going to happen on this one? You're right. It's going to go the same way. It's going to become 3/2 raised to the 4th, which is going to give us 81/16. Folks, that's the concept of what happens when we raise to a negative exponent. It's all about reciprocals, and then raise it to the positive power, which we can do, right? You got it. We can all do those kind of things. So there you have it. Speaking of things you can do, let's get a call in if we can. 844-686-2378. That's our number. That's our number there. And I've been mentioning one more thing on exponents. Why not? We've kind of had a theme on that today, haven't we? Looked like it. And let's just do it one more time here. Let's look at a quick scientific notation type problem. I don't know that we'll get both of them in, but it would be nice if we could. This basically is a multiplication symbol. So you're like, oh, thank goodness it's not an X, it's not an algebra type thing. Well, no, it isn't. But what it's telling me is, here we do want to take that 3 and raise it to the 2nd power. We also want to raise our 10 to the 4th, which is some pretty exorbitant number, like what, 10,000? Raise it to the 2nd power, but we're going to keep scientific notation. Oh, and then we're going to come up with standard notation. So let's see what happens. Raise the 3 to the 2nd. We know that. Not 3 times 2, is it? It's 3 times 3, which gives you 9. How about this one? Multiply the powers this time. Now, you say, Ernie, why did you decide you're going to multiply the powers this time instead of 4 to the 2nd? Because it's exponent times exponent here. This was base. The base here is 10. We've already raised it to 4 power. It's like saying, let's say 10 to the 4th times 10 to the 4th, which basically means we just doubled the 4, all right? So this is going to give us times 10 to the, not to the 18, sorry. It's going to give us 10 to the 8th power, jumping the gun a little bit. And that's the scientific formula. Let me make it look a little prettier, all right? There we go. 9 times 10 to the 8th. That means if we put a 9 down here, oh my goodness, how many zeros do we need? We're going to move that decimal to 8 places. So we're going to add 8 zeros. I think I feel a lot of money coming my way here. My goodness. There's, 900,000? No, 900 million. Woo, that's good. $900 million or whatever there. Now that's where you go on those kind of things. Now over here, some of you are probably going, oh, I know it's going to be 3 to the 3rd. And then you're going to do what? You're going to multiply those exponents. So you're going to have something like what, 27 times 10 to the 12th? And we're going to run out of time because the problem's not done there. We don't quite have scientific notation. Ooh, no, we don't. We have 27, which gets us out of the range. We'll put this one back up tomorrow. We'll finish it out, okay? But right now, I know we're getting close to the end of the show, and I don't want to get stuck in the middle of the problem, which has happened before. And by the way, folks, although none of you seem to call in today, that's okay. You can give us a call tomorrow, and we'll be back live again tomorrow. That number, put it in your speed dial, 844-686-2378. It's always nice to have you call in. It's always nice for you to tune in. Give us some calls, all right, the next time. We will be back in live tomorrow, hanging out. And I don't know who will be, but hopefully have some more Bearden kids here. We may have them, all right? And hopefully we'll have you. And thank you again for tuning in this afternoon. And it's been a great show. We got a lot of exponent work done. And you know what? We'll get back with some more work next time. And we hope to see you then back again.